The negative and the positive.
What is happening in an adiabatic expansion that doesn't happen with isothermal? Remember, adiabatic, they're both expansions, right? Adiabatic expansions change the temperature. Isothermal, does the temperature change?
No.
No, because isothermal means same temperature, right? Okay, so one of those, adiabatic, is going to be colder at the end, right? So which one's colder, A or B? This should be glaringly obvious. Which one's colder? B is colder. How do we know?
Because the pressure is lower.
Because the pressure is lower. Colder is less pressure, correct?
Yeah.
For a confined gas at the same volume. They both have the same volume. This one's colder. In fact, you could even look, if this is 100 degrees, that one looks to be about 20 kelvins. Not degrees, but kelvins, right? Okay? That's 100 kelvins. That's about 20. It's about 1/5 of the way up. Okay? Okay, so let's do the opposite of this. Argue it out. One's adiabatic, one's isothermal. What are they, compressions or expansions? Expressions. They're expressions. They're compassions. Compansions. They are compressions. Simply they move this way, more this way, right? So that's compression. This is expansion. Compression, smaller volume. Expansion's bigger volume, right? B is adiabatic. A is isothermal. Why?
Because B has more pressure. It's getting hotter.
Compressions get hotter. Isothermal can't get hotter because it's of the definition, right? So the hotter one is B. Therefore, it must be the adiabatic one. If one's adiabatic and one's isothermal.
Like it makes sense.
This is your brain on physics, right? Is that it? Is our brain full? A complete cycle. Holy cow. Okay. Now just take a look. Oh, are we running out of time right now? Almost. Think about this, right? What we do is we heat it up, right? We allow it to expand at a high pressure. We cool it down and compress it at a low pressure.
Is that done simultaneously?
No, all one, then the next, then the next, then the next. Now, think about this. Are we doing more work on the world, or is the world doing more work on us? Same change in volume, but is it the same work?
No.
Not the same work because why? The pressures are different, aren't they? Which one requires more force or exerts more force? Is it the high pressure one?
Yeah.
High pressure is higher force, right? So this is more work than this guy. So it's actually doing more work on the world than the world does on it. This is your car. Your car does this. It expands when it's fiery hot under high pressure. It compresses at cool pressures, at cool temperatures.
Does it do crazy stuff too?
Yeah, it's not square. It's not a square.
Oh, yeah, my car.